Hi, I'm Robert Green, and I'm going to be speaking to you today on the path to universal newborn sequencing. I'm really excited to be here because this is such an exciting area. It's a transformational area, and as you can hear, we finally got enough evidence, I think, to move forward with the excitement that this area deserves. I would like to declare my conflicts of interest and research support here. Most of my research is supported by NIH with the additional funding support you can see there. I do compensated advisory to several companies, and I'm a co-founder of 2 companies there. And I'm also very proud to be speaking to NBSTRN today because BabySeq that you're going to hear about was one of the first studies, if not the first, to deposit genomic data into the longitudinal PDR at NBSTRN, and it continues to do so today. And as you're going to see, we have a very large team, and many BabySeq team members lend their expertise through service on the NBSTRN steering committee and expert working groups. Now, the core of our program we call Genomes2People, and you can see that we have a relatively small core of people that's been together for quite a few years, focusing on the medical, behavioral, and economic costs and benefits of using genomic data in clinical medicine, or so-called implementation research. But for the projects I'm going to be talking to you about, we actually have a very large set of collaborators in multiple sites around the country. So I want to acknowledge all of them first, particularly as we turn to BabySeq, Alan Beggs and Ingrid Holm, who've been the MPIs respectively of BabySeq 1 and 2, and Casey and Bethany, whose photos are down at the lower right, who have been the project managers for BabySeq 1 and BabySeq 2. So this is a huge team that I have the privilege of speaking for today. I'd also like to mention that our programs mentor trainees at every level, including geneticist trainees, pre-docs, postdocs, junior faculty. We do so both in person and virtually during summer sessions in particular, but also around the year. So if anyone listening to this would like to come and work with us, please contact us because we'd love to talk to you about that. We have very, very active training programs. And finally, as part of our introduction, I'm really proud that our program is committed to diversity in genomic medicine to the best of our ability. Notably, we've had the very first research study to offer subsidized elective sequencing to healthy African American adults from an HTRI, the very first research study to return genomic results to African Americans in the All African American Jackson Heart Study. And now with BabySeq 2 from NCATS, the very first NIH study to offer whole genome sequencing to African American and Hispanic newborns in both English and Spanish. So we know that there are a lot of issues with disparities we're not going to be talking about in this presentation, but I do want to note that we're doing our best to try to redress those through our research as well. The story that I'm going to tell you today starts about 10 or 12 years ago when we wrote the first NIH grant to sequence apparently healthy adults. And we proposed that we should simply sequence these adults in a primary care setting and let the results speak for themselves. And we should cast the broadest net possible. In fact, we looked at over 5,000 disease-associated genes. And when we did that, to our astonishment, we found that 20% of these apparently healthy adults were carrying a monogenic disease risk. That's what MDR stands for in this slide. Now, you could say to yourself, that's crazy. 20% of people walking around don't have a genetic disease, but it turned out that about a quarter of them did have an ongoing genetic disease. It had just been misdiagnosed or unrecognized. And the others were at risk for a genetic disease, like a form of cancer or a form of heart disease, but they would continue to be at risk for throughout the rest of their lives. And in separate studies, we demonstrated at the 50-year Framingham Heart Study that in fact, the people who carry these mutations, if you followed them long enough, were very likely to manifest some feature of the underlying monogenic disease. So we demonstrated that there's probably a lot more genetic risk than we ever realized, and added to the power of the argument that we should be looking for these things. And we published over 50 papers, if you can believe it, from MedSeq. So I'm certainly not going to go into all that data today. But the offshoot was that we found that about 20% of apparently healthy adults were carrying monogenic, dominant, or biallelic mutations. So they were at risk for a monogenic condition. About 90% of them were carrying a monogenic recessive mutation, at least a single one, which would put their children at risk if paired with a similar mutation in their partner. About 80% had an atypical response to medications, and about 50% had some form of elevated polygenic risk score if you looked for enough conditions. So when you put all this together, you've actually got a genome with a huge amount of usable information. And this is sort of the tragedy of genomic medicine to this point in time, is that we haven't been putting this together. These things are all balkanized within different parts of medicine. We haven't been putting these together to ask ourselves, what can we learn from a comprehensive human genome? Now, when you think about this, you're really moving in from the area of diagnosis, from indication-based diagnosis, into the area of screening. And our perspective changes, our vocabulary changes. We should not be speaking about diagnosing in a screening environment. We should be talking about risk stratification, because we are taking people who don't have an observable condition, and we are asking, what's the likelihood that they have one that we've missed, or that they will develop one in the future? And when we do that in genetics, we're of course talking individually about rare conditions. And out of this discussion arises the pros and cons that we're all pretty familiar with around population screening. And that is, of course, that you can, with DNA first, make a diagnosis of unsuspected genetic disease by first finding a risk variant and then following up with orthogonal testing. You can risk stratify if you can't do follow-up testing, and many people, more and more generationally, want to know what diseases they're at risk for, and they want to know many times, even if they can't treat it. On the other hand, we're talking about rare conditions with a low prior probability. So even if you get the variant calling perfectly right, you are identifying people who are at risk, but who will never manifest the condition. I wouldn't call those false positives. I would call those people who are at risk who don't manifest the condition. So that's a concern. You could generate a whole lot of downstream follow-up and expense. You could generate a fair amount of worry, although we've demonstrated time and again that worry isn't an issue. And ultimately, you've got unproven clinical utility and cost effectiveness, not to mention that the issues that the current genetics workforce is pretty overextended as it is. And if you're screening the entire population for new at-risk cases, you really got a problem. Nonetheless, this is the challenge I believe we have to take on. Now, rather than taking it on in adulthood, the most logical place to take it on is in babies. And of course, this potential has been recognized really for 20 years, but here's one from over 10 years ago where Francis Collins said, whether you like it or not, a complete sequencing of newborns is not far away. And you know, I think he meant, I've actually talked to him about this, he meant sooner than now. So it's a little surprising, but not too surprising that it's coming now. Now, we know that a lot of babies are born with treatable genetic conditions that are not getting recognized by the state-mandated newborn screening program. In fact, you could estimate that there are over 100,000 babies a year who are manifesting risk variants, and at least 26,000 a year that are actually manifesting disease conditions that are treatable in these various modalities, but are not getting recognized and are not getting treated. And we could estimate that there are many more to come, that the development of treatments, whether they be in any of those modalities, are outstripping by far the process that we have to put conditions on the RUSP and get them into the state labs. And likely we need an entirely new paradigm for consented sequencing than we've used for unconsented newborn screening. So with that in mind, in 2015, we began the BabySeq project. And it's an NIH-funded randomized clinical trial in which we propose to do comprehensive sequencing of apparently healthy newborn babies. And to do this, we designed a study flow. It was very, very simple. We took volunteers, we randomized them into 2 arms, we followed them with exactly the same visit structure, except that in one arm, we gave them a family history report that was as comprehensive as we could make it, so they got something. And the other arm, we gave them that same family history report, but a genome report. And in that genome report, we decided, after much effort, to give them approximately 1,000 genes. How did we come up with those 1,000 genes? Well, there's a 2017 paper that explains it in depth, but in brief, we tried to lean into genes that had high gene disease validity. So we didn't want to be giving back genes that weren't actually associated with any disease. We then selected for genes that had effectively an approximation of higher penetrance and younger age of onset. And we came up with about 884 genes. We then added another 70 genes with cancer predisposition syndromes that could actually strike in childhood or adolescence, and we ended up with 954 genes. By the way, we later added a few additional genes that represented adult onset cancer and other conditions from the ACMG list. And we did that because we actually found some babies carrying those mutations, and we were put in a position, a real moral quandary. But again, the selection of genes, I think at a high level, it's really important to realize the selection of genes has a different conceptual basis for screening than it does for diagnosis. If you imagine a sort of 3-dimensional space where you're comparing disease gene validity on one axis, variant pathogenicity on another axis, and clinical actionability on a third axis, you can create this sort of larger 3-dimensional space that you see here, which we classically use today for indication-based testing. In the NICU, in every genetics clinic around the country, we will look for disease genes that could involve a brand new gene, perhaps. They're often done at academic centers. They're often done with the spirit of discovery. So there's a way of looking for new genes in that zebra patient that you find. We also, in clinical practice, we report out pathogenic, likely pathogenic, and variants of uncertain significance. And then we're not so concerned at the diagnostic level about clinical actionability because we're most focused on molecular diagnosis. We want to use this information for prognosis as well as for treatment. But if you look at the smaller box, it is a really different concept for reporting screening, in that you want to minimize identification of variants that are never going to develop the condition. Therefore, you're going to want to select for clearly established disease gene validity, clearly established pathogenicity, and of course, you may offer for some families untreatable conditions, and we can debate on the nature of what treatability is. Many people would consider early intervention in autism to be a treatment, but there's certainly gradations of treatment, and we're all going to lean toward those conditions where there is more clear-cut treatability and even curability and prevention than not. So the search space, if you will, becomes lower. Now, another legitimate question you could ask, and that we did ask, is do families really want this? Would they really, if you could offer it, will they come? And I can tell you right now that that depends entirely on how you frame the question. So for example, in a hypothetical survey of actual parents on the newborn birthing unit, we asked 1,300 parents, new parents, whether they would want to participate in a research study where their child would get comprehensively sequenced for mostly treatable conditions, and they overwhelmingly said they were interested. So looking at the big picture, this is 70% of the total population, if you can extrapolate to the ones who declined the survey. By contrast, we as the first study in the world to offer this, went through an incredible gauntlet of committees, safety concerns, advisory committees to the advisory committees, 2 separate reviews by 2 separate IRBs, an independent review by the FDA. And what we ended up with was a tortuous consent process. Honestly, it's not something you would wish on anybody. And in that scenario, once we approached families, almost all of them said, "Are you kidding? I don't want to be involved in research." But then when they sat down and went through the study with us, the 10% who did or so, about 2/3 actually did enroll. Now you contrast this with Wendy Chung's experience that she's reported at several recent meetings, where she is framing a more limited amount of newborn sequencing as a simple research add-on to the ongoing blood heel stick that the baby's getting. And in that sense, she's getting about 70% consent, very much like we got in our hypothetical. So the take-home lesson here is, if you can offer consent without scaring people and without putting them through elaborate consent process, we think about 70% of people want this. And to skip quickly through the results of BabySeq 1, in about 159 infants, the first 159 infants sequenced with 1,000 genes, we found 11% had monogenic disease risk. You can see what they are here. And in the phenotypic evidence column, you can see that about 1/4 of them, again, actually had evidence that was either misdiagnosed or underdiagnosed. So for example, that third column there with the elastin mutation, rosy-cheeked baby, perfectly normal heart sounds, and yet when an echocardiogram was done as a follow-up to this mutational finding, the baby was found to have abnormal degree of supravalvular aortic stenosis. Now this might never affect that child, and you could, that's a glass half empty for the sequencing, like, oh, you've identified this and the family's going to worry. On the other hand, if this child goes out and has any symptoms whatsoever, you have shortened that diagnostic odyssey enormously, because this is one of the first places you now know to look. And as you can see, we did identify some hereditary breast and ovarian cancer cases and a Lynch syndrome case. And as I'll tell you a little bit later what had transpired with that. But what was fascinating is we learned from this that we could not, in good conscience, know that these babies had this, and that therefore one of their parents was carrying it. Their parents did not know without disclosing this. And so we moved to disclose these, which is, of course, in something in tension with current pediatric genetics recommendations. But we still feel it was and is the right thing to do. It's also interesting that when you do look for a lot of biallelic babies at risk, you find a lot of carriers. And we found an enormous number of carriers, much bigger than the number that's included on even the biggest commercial panel. And importantly, for those who are still worrying about psychosocial impact, distress, this is one in a series of dozens of papers that we and others have published, demonstrating that there's a self-selection going on, that family members who volunteer for studies and eventually clinical experiences like this actually do want to know. They're actually not overly distressed by the findings. You can see here that those parents who took part in this study, whether they received no genome sequencing at all in the control group, whether they were in the control group who got sequenced or they were in the subset who were returned monogenic disease risks, their depression, anxiety, self-blame, or there was no disruption in parent-child bonding. And for those who are appropriately concerned that we're going to somehow bankrupt the healthcare system, yes, you do spend more on babies who are determined to have monogenic disease risks. And overall, on obviously, if you include the sequencing and the sequencing arm, yes, you do spend more. But that's actually an advantage from a healthcare system point of view, though a disadvantage from a societal point of view. And it turns out that the difference is pretty small between those sequenced who have monogenic disease risk and those sequenced who do not have monogenic disease risk. Surprisingly small. And there's a lot of noise in here. So yes, there's follow-up. Yes, it costs more. But on the big scale of things, this is a logarithmic scale on the right, it's not hugely different. If there were guidelines for exactly what you work up and what you don't, I think this differential could be even lower. Now, here's some of the fascinating unpublished data that is in press and will be published in July. Of just 18 babies with monogenic disease risks, we stimulated all of the infant workup you can see there, the specialty consultations, the imaging studies, the ongoing treatment, the diagnostic interventions, and so forth. What we did not expect was the degree to which this would filter out into the families, and with a modest amount of support from our genomics team, would translate into specialty consultations, imaging studies, ongoing surveillance, cascade testing, and if you can believe it, 3 risk-reducing surgeries in the 3 mothers who were discovered to have adult onset condition risk. So the 2 BRCA2 mothers and the 1 Lynch syndrome mother who had her uterus removed all had risk-reducing surgeries. And I have to tell you that when I talk about this, sometimes I get goosebumps because we may have saved those mothers' lives and saved those children the burden of losing their mothers early, which has got to be an advantage in their life. And we could have a side conversation about the ethics of this. I know there are many who disagree, but I'm fully convinced now that this is far more beneficial than is the theoretical risk of taking away this child's ability to choose for themselves if they want that information when they're older. We've been fortunate to generate a fair amount of attention, and I believe we've helped move this field forward in terms of creating an appetite for newborn sequencing. And of course, there are many other groups now that are starting to consider to do this, and we'll talk a little bit about them later in the talk. And we've been able to share real stories of parents who have undergone this as part of it, and you're going to see a video toward the end of this talk with some of these voices themselves. Now, it took us a while. This is very controversial, and as you might imagine, there were many people at the beginning who felt that this was premature translation, that we were endangering families, and that we really shouldn't be doing it at all. And there are still many groups in our discipline who believe that, and I hope we can convince them with our real data. But we eventually got a second grant funded, which we are internally calling BabySeq 2, really just an extension of the BabySeq project writ large. And in this one, we have made the commitment to do a much more diverse recruitment at multiple sites and from multiple diverse groups. And so thus far, we have 2 new BabySeq sites in addition to the 3 that were funded by NIH. And we have several other sites that we're onboarding. And if your site would like to participate, whether you're an academic healthcare center or a regional non-academic healthcare center, if you would like to participate in BabySeq 2 and have some capacity for self-funding, we're trying to raise additional funds, but these sites actually self-funded, we would love to talk to you about expanding the BabySeq network. BabySeq 2 has a similar, slightly more streamlined protocol, but it's also being run as a randomized clinical trial. So we are at a point in time where we've made the effort to have a culturally appropriate materials, partner with community clinics, training pediatricians, interviewing parents, and we intend to enroll at least 1,000 families and possibly 5,000 to 10,000 families, depending on how many sites would like to join us. And look, I think the idea here is not just to be to sequence once and be done, but to create a lifelong health resource where genomics can be consulted for the health of the infant, the health of the child, and the health of the entire family. Now, I'm also really proud to say that this experience of trying to refund the grant and some of the resistance and criticism we got in these early days made me very sympathetic to what I knew were going to be the other groups in the world who were coming. They were talking to us, we were consulting to them, we're coming along. And figuring there was better safety in numbers, I reached out to David Bick, and together we've created the International Consortium on Newborn Sequencing, with the first product being an international conference on newborn sequencing. On that first conference, we took the eight groups in the world that we knew were either doing or about to do newborn sequencing, and we created a steering committee, as you can see here. And that steering committee has now created the icons. And we had our first conference in October in Boston. It was a huge success. We had some of the most earliest pioneers, like Rodney Howell up there speaking to us. We had ethics, we had Genomics England, we had representative of the Child Institute, you can see Diane there. We had just an outstanding faculty, and we've gone forward with a new executive director, Nick Encina, a website you can see there, icons..org, and monthly meetings that are open to everyone who would like to join. If you want to contact Nick at the information on that website, you can join as an individual or you can join as an institution. And I'm super proud to say that we've just secured the Royal Institution as the conference site for the ICONS meeting in October of 2023. This is where Galileo and other notables have spoken. So it's fantastic to be joining there. I hope you'll all come to that meeting in person, but you can also, for the exact same price, you can also attend it virtually. Now, just last week, a week ago, with the BabySeq team in conjunction with a number of outside experts and led by Nina Gold, a young faculty member at Mass General Brigham, published the first study ever on the perspective of rare disease experts on newborn genome sequencing. And for this, we took all the various sources that have been touted for treatable disease gene pairs. We reduced them to 651 genes, and you can see in all of the 11 categories of specialty that you can see at the bottom of that figure. And then we essentially asked several hundred rare disease experts, some of you may have filled this out, thank you, if they would rank them according to the genes that they would look for first on a panel of newborn sequencing. And the result is a kind of roadmap where the very first genes, for example, that had 90% concordance are these. And you can now march down the list and you can see the top 8 genes, top 10 genes, the top 25 genes, the top 50 genes, and so forth. In fact, there were over 400 genes for which there was 50% concordance or more. So there's also a table in this where all of these experts put their heads together, and table 3 shows all 651 conditions with, at least at this moment in time, what to do next if you find a baby with this mutation. What's the orthogonal test do you do? Now, this is not a dashboard. This is not AI driven, and it's certainly not up to date for the latest. But I think it's going to be a great start for people who are starting to find these mutations one way or the other, and who want to know, get a start on what to do next. Now I'd like to share with you some actual voices from the parents of babies who are enrolled in the BabySeq project, telling you in their own words some of their experiences and how they feel about this.
We just thought, like, why isn't this done for everybody?
I think part of the attraction of participating in the study was having that information and how empowering that information would be.
Let's be real. I mean, when you have a newborn, it's kind of like your whole world changes. So knowing a little bit of information is going to be helpful down the road.
We just want our children to be healthy and happy. And if we could know that what could potentially be harmful to them, we can hopefully act on it.
I got involved when my son was born in January 2016. He's now 6.5. When we got the results for my son, we had learned that he was a carrier of something called supravalvular aortic stenosis. I learned that it can cause a narrowing of one of the valves in the heart and potentially could cause significant health issues for him down the line. You know, you think about those high school football players that just fall over and die in a football field because they had a heart condition that nobody knew about. And then so I was like, oh, well, if they had only known, if there was some way to know. So I always kind of comforted myself by thinking, at least I know it.
The most critical thing that they found with my son is that he has the BRCA2 mutation. I was told that I had a significant mutation that is a high propensity for a couple different types of cancers and that I should start to look into that. I would rather my boys have me for longer than me get something that I know is a higher risk for me. I'm not willing to accept the risk of cancer and leave my kids motherless. And so overall, just so happy that we have opted in, that we know our risks, that we're taking action steps to, extend our life.
You already do some screening, obviously, like by default. Right. So this was just, to me, this was just like an extra feature of screening, of being able to see more and kind of dive in more and be able to know more, ultimately, so that you are prepared.
It's just, in the long run, it's more beneficial to our society, to our world, to our history.
You don't see a lot of people with color. You don't see our demographics being represented. We have to count, and that's why we did it.
It was a really positive experience for our family, and we would participate again if we had the opportunity.
It has been a journey that we are happy that we opted into.
And I just felt more so empowered to have the information than not. And I think that, with everything going on in the world, with all our resources, we should know more so that we can do our best for our kids.
So I leave you with their voices and a couple of pieces of information. Please feel free to go to our website and see our publications. All of our full text publications are there. Please feel free to follow us on social media. And if there are any questions whatsoever, or you'd like to collaborate or have one or more trainees come to work with us, we'd be delighted to talk to you. Feel free to email me at my email there. And thank you so much for the opportunity to speak to you today.